Okay, so welcome back. Now, recently I had the opportunity to tear down and look at upgrading this 7-year-old HP Envy desktop computer. And you can imagine it had some very old components. Originally, it had a GT700 series GPU, and it had been removed. I took it out and I was using the heatsink and fan off of the GPU, and instead this desktop was using its internal graphics chip. So what I decided to do is to put that GT730 back together. I'd have to put the fan and heatsink back onto the GPU, and in order to do that, of course, I had to clean it off and put in some new thermal paste. What I looked at was doing some benchmarks with that GT730 with the new thermal paste, and I thought I would compare it to another of the same vintage GPUs. This is a GTX 745 that also came out in 2014, but this has never been touched. Very similar GPU, but it's operating on thermal paste that is probably 7 years old. So what I thought I'd do in this video is to do benchmarks on both of these GPUs and see if there's any thermal difference in these two GPUs, one with brand new thermal paste and one with 7-year-old thermal paste. Again, they're very similar GPUs. They should have similar performance. So what we're going to do is we're going to see the difference. And if there's a big difference, if this older GPU with the old thermal paste is running a lot hotter, what we're going to do is we're going to change out the thermal paste and see if that makes a significant difference in the temperatures. Okay, so inside the desktop, here is the old GT730 that came with the computer. And this is the one where I recently put this back on, the fan and the heatsink, and added some new thermal paste. And you can see it's pretty much very similar to this GTX 745 with the old thermal paste. So what we're going to do is we're going to do benchmarks on these two GPUs using a 3D render benchmark. And this is going to be out of Blender, which is a 3D rendering software. And we're going to render a 3D image using both of these GPUs and check the temperatures of these two GPUs while we're rendering and see if there's significant difference. Does the thermal paste, the new thermal paste on this GT730 give a lot better performance, a lot lower temperatures than the old thermal paste on this GTX 745? So let's go to the computer and run some benchmarks and see what we get. Okay, so here we are in Blender, 3D rendering software. And what we're going to do, I'm starting out with the, you can see down here, NVIDIA GeForce GTX 745. This is the GPU with the 7-year-old thermal paste. And what I'm going to do is I'm going to run a 3D render, and this should take about an hour to render this 3D scene. And I'm using a standard benchmark scene in Blender. And I'm going to monitor using GPU-Z. You can see here I'm monitoring temperature, fan speed, memory used, GPU load, and also performance cap reason. This tells you, as you can see here, if there's any limitations, if it's going to throttle back the GPU based on getting too hot or too low operating voltage or whatever. So that will at least tell me if I'm doing a render and one of these GPUs or both is being throttled. I want to make sure that, you know, we're comparing apples and apples and we're having both are being utilized the same amount. So what I'm going to do is I'm going to do a render and I'm going to log to file. I'm going to save as a log file, and I'm going to open these results up in a very nice application that will allow us to graph this over a long period so we can compare the results very easily. So I'm going to close this and I'm going to start a render. Okay, so you can see now I'm doing the render. I've got the GPU load at 100%, and the GPU temperature is 70 degrees C, and it seems to be climbing a bit. So what I'll do is I'll let this run. It's going to take about, if you look up here, remaining about 50 minutes to do the complete render. And it's up to 72 degrees C, 73 degrees C. So we'll let this run for about an hour, and we'll come back and we'll look at the chart of the temperatures of this GPU, and then we'll do the same thing for the GT730 that has the new thermal paste and see what the temperatures we get for that. Okay, so the render is done, and here is the output, and I brought it into a wonderful application called Generic Log Viewer, and it allows you to plot GPU-Z and other applications outputs over a period of time. So you can see it went for over maybe up to 50 minutes to do the render, and this is the GPU temperature in degrees centigrade. So you can see it starts out around 50 degrees centigrade and it gets up to almost 86, 88 degrees. And you can see it stays flat around 86 for the entire render and then drops off. So we can also look at the fan speed. You can see the fan speed goes up and then bounces around. We can look at the GPU load. You can see it's 100%, no question, for the entire time. And performance cap reason, basically nothing. There was no performance caps. So if it's at 0, you can see it's down at 0. If it's at 0, that means there's no performance cap, which means it was running pretty much flat out. So now what we'll do is we'll run the same thing for the GT730 with the new thermal paste and see what we get. Okay, so I went ahead and I rendered with the GT730 with the new thermal paste, and this is the result. You can see here's the results from the GTX 745 with the old thermal paste, and below it on the same graph, I've got the GT730, and you can see while the old thermal paste GPU got up to 80, almost 88 degrees C, the one with the new thermal paste reached about 50, maybe 52, 53 degrees centigrade. So a huge difference in temperatures between the old and the new thermal paste. So then the question is it just the thermal paste or is there something else going on? So what we're going to do is I'm going to take this old thermal paste GPU, clean it off, put in new thermal paste, and then run this again to see how the results are compared to the new thermal paste. Okay, so here's the GPU with the old thermal paste, and I took apart the heat sink and the fan, and you can touch this and see it's very dry. Again, 7 years old. So what I'm going to do is take some IPA and clean it up a bit, and then we're going to put on some new thermal paste and see if that makes a difference. Okay, so it's reasonably clean, and I'm going to put some Arctic Silver. I know the hardware fanboys are going to require I use Arctic Silver. Put a little blob of Arctic Silver on there and rub it around. Okay, so it's all back on. What we'll do is we'll take back to the computer and run a benchmark and see what kind of results we get. Okay, so here we are doing our render, and you can see we're about 20 minutes into the render. And if you look at the results so far, GPU temperature is at 86 degrees C, which is just a tad below what it was with the old thermal paste. Fan speed is 46. This has been flat at around 86, 87 for a long time, which means the GPU is doing what it should. It is maintaining a safe temperature below like 100 degrees C or whatever. The fan's spinning, it's doing its job. GPU's at 100%, no performance cap. So it's going well, it's doing what it should, but really it seems like that thermal paste really didn't do much at all. There's maybe something else going on, but we'll wait until this is done and look at the final charts when it's finished. Okay, so here we are with the final results, and I've got on top here, I've got these two charts which are virtually identical. And those are the GTX 745 with old and new thermal paste. And you can see there's virtually no difference. Rendered the same amount of time. Basically everything was identical, no difference. And neither of them are even close to this GT730, which is down at like 50 degrees C compared to 85, 86 degrees C. So then the question becomes, does the thermal paste age really matter? This data seems to show that it makes virtually zero difference. You know, 7-year-old thermal paste may be identical to new thermal paste. The other question is, why is there such a big difference in temperatures of the GPUs doing the exact same work? Everything was working fine. We know that this GPU with the high temperatures was doing its job because you see the temperatures are flat, which means that The system, the GPU, fan, and performance was responding to maintain the temperatures around 85, 86 degrees C, which is considered by the manufacturer to be a safe temperature. That's why it's flattened out here, because that's what they want. They want the GPU to operate in this temperature range, because if it gets up around 100 degrees C, it could get damaged, or maybe significantly above 100 degrees C. So this is fine. 85 degrees C is fine. The question is, why the difference? But does it really matter at the end of the day? Clearly 85, 86 is the temperature desired by the manufacturer, because that's how they have the fans and the performance set up to flatten out at 85 or 86. So really, it's not a big deal. Does it really matter? Probably not. It might be an interesting thing to go ahead and figure out why there's a difference in temperatures, but you know, at the end of the day, so what? I mean, your 85, 86 is a reasonable temperature, so does it really matter? Now, I know there are the people who are going to say, well, you know, it might shorten the life of the GPU, even though it's 7 years old. You know, are you going to, you know, how much longer are you going to use it anyway? So people will come up with a reason to support whatever they want to believe. But personally, I don't think this makes any difference at all. I mean, are you going to use this for heavy-duty rendering in the first place? And so what? So anyway, interesting. It might be a nice project to figure out the difference between the temperatures, but at the end of the day, maybe it doesn't really matter. So if you like any of these videos, please hit the like button and subscribe and the bell notifications, and most of all, let others know that we're here so we get some more viewers. Otherwise, hope this helps. Take care and have a really good day. Thanks.